Hi guys, in this video we're going to have a look at inequalities and also how we draw them on a number line. So, what's an inequality look like? Well, we use these symbols here and we always read left to right. So going from left to right, this symbol means it's greater than, and if you see this little line underneath the greater than sign, it means that it's greater than, but it could also be equal to. And then obviously we've got these ones down here, so the sign's the other way around. So again, reading from left to right, this means that it's less than, and again, if that line underneath it is there, it means that it's less than or equal to. Now, people get a little bit confuzzled with which way round or which number is bigger than the other. So the way I always think of it is you're always pointing, the inequality sign is always pointing at the smaller number. You can also sort of think of inequalities as bullies, if you like, and they're bullying the little number by pointing at it. Okay, so the inequality sign is always pointing at the smaller number. Okay, that's one way to remember it. So if we have a little look at some examples here, reading left to right, so x, the inequality is pointing at 4, so 4 is the smaller number, so x therefore must be bigger than 4 or greater than 4. So we could have some examples like 5, 6, 7, 8, and so on and so forth. Okay. This one here, x, we're reading left to right. This time the inequality is pointing at x, which means that x is the smallest number. So if 3 is pointing at x, x must be less than 3. So again, a couple of examples, 2, 1, 0, minus 1, and so on and so forth. This one here, again, it's pointing at x, so x is going to be the smallest number. So if I've got minus 2, that's the biggest number, x must be smaller, but again, I've got this little line here which tells me that it could also be equal to minus 2. So I'm going to put minus 2 in there, because it could be equal to minus 2, and then numbers less, so minus 3, minus 4, minus 5, and so on. This one here, again, it's pointing at 6, but this time x is on this side, which doesn't mean any difference, because remember, the inequality sign is always pointing at the smaller number. So it's pointing at 6, which means 6 is the smallest number, so x must be greater than 6. But also, remember that little line there, so it could also be equal to 6, so it could be 6, but then numbers that are bigger, obviously whatever you want, bigger than 6. Okay, so that's how the general inequality signs work. And as long as you remember you always point at the smaller number, you should always get it the correct way round. So how we draw them is like so. If we've got the number 4, the first thing to do is to put a circle over 4. Okay, and now x is bigger than 4, so when you've got your number line, if x is bigger, we draw an arrow going up the number line to show that it is bigger than 4. Same thing for here, we put a little circle on 3, and this time, if you remember, x was less than, so I put an arrow going down the number line to show that it was less than 3. This one's a little bit different. You still put a circle over minus 2, but this one here means it's equal to, and this one here wasn't. So obviously we need to have something that indicates that it's equal to, and you might have already spotted it on my sheet here. To show that it's equal to, we actually do a solid circle. So we colour that in, and that proves that it's equal to minus 2, and then obviously it can also be less than, so we still draw our arrow. So it's less than or equal to. So if it's not equal to, leave it as a clear circle. If it is equal to, you colour it in. So this one here, I'm going to put my circle over 6. It is equal to, so I'm going to colour it in. And this one here, we're saying x is bigger, so I draw an arrow going up my number line. Okay, so solid circle means equal to, clear circle, not equal to. Okay, so that's some basics. Let's go on and step up a notch. Let's get my next sheet. Okay, so you could have something that looks a bit like this. So this time we've got 2 inequalities. But don't let that put you off, because all they're saying is that we're pointing at 9, so x is bigger than 9, but then this inequality here is pointing at x, so x is less than 15. So x is bigger than 9, but less than 15. So what could I have? Well, I could have 10, I could have 11, 12, 13, and 14. I can't have 9, I can't have 15 because these haven't got the equal sign or the little line underneath, so it's saying it's not equal to. So they're the numbers I could have. And how we draw that is we put a circle over 9 and we put a circle over 15 and we join them up, and because, as I said, they're not equal to, I leave them as clear circles. Next one here, so again, x is greater than 23 because it's pointing at 23, so that's the smallest one, and we're pointing at x, so x is smaller than 26. But notice here I can include 26 because I've got that little line saying that it's equal to. So I can have 24, 25, and I can include 26 with the solutions that x could be. How we draw that? Circle over 23, circle over 26. Because it's equal to, I can colour that one in, and again I join them up. This one here, x is greater or equal to 2, x is less than or equal to 7. So it's in between these two. I can include the 2 and I can include the 7 because I've got the little lines underneath my inequality. So the solutions here, 2, 3, 4, 5, 6 and 7. So how I draw that, circle over 2, circle over 7. Because they're both equal to, I can shade both of them in, and then I just draw a line in between them. Obviously you've got ruler. Ruler is probably a better shout. And this one here, exactly the same thing. X is bigger than minus 14, but x is less than or equal to minus 10. So I could have minus 13, minus 12, minus 11, and I can include minus 10 because it's equal to. So how we draw it, circle on minus 14, circle on minus 10. The minus 10 one has a equal bit to it, so I can shade it in, and then I just join it up. Okay, so if I've got some drawings and you've been told to work out the inequality, how do we do it? Well, we always start off with x. To be fair, you might do either way around you want, but I always start off with x, and we have a look. I've got the number 1, so I'm going to put the number 1. And looking at the number line, we're saying that x is greater than, so x is bigger than 1, which means that 1 would be the smallest. So I'm going to point my inequality at the 1 to show that x is bigger than 1. And because it's a solid dot, I'm going to add my line there to show that it's also equal to. Exactly the same thing here. Let's start off with my x. The little circle's above 12. So this time we're saying that x is less than, it's smaller. So x is the smaller one, so I'm going to point my inequality at x, showing that x is less than 12. And because it's a clear circle, I don't add my little line. And the same thing here, I've got x, the circle's above 2, and my arrow's going down, so x is going to be less than 2, so x is the smallest one, so I point it at x. This time it is a solid dot, so I add my line. And then finally, going back to these ones here, I'm going to have a 2, because that's where I've got a circle above it. I'm going to have a 6, and I'm obviously going to have an x. And quite simply, x is going to be bigger than 2, so I'm pointing at 2, and x is going to be less than 6, so I put it pointing at x. That one's a solid dot, so it's equal to, so I add my line, and you're done. Exactly the same thing here. I've got a minus 7 and a minus 2, so minus 7, minus 2. I'll put my x in. X is bigger than minus 7, so I'm pointing at minus 7. But x is less than minus 2, so I point at x. Both are coloured in, so both are equal to, so I add my equal to signs there. And again, we're done. And last thing just to show you on this video is questions like this, which tend to trip people up, but they're really easy, is when you have an inequality like this, where we have 2x, or a 6x, or a 5x, or anything like that in the middle, whereas we're used to seeing x. So that is what I want to change it to. I don't want it to be 2x, I want it to be x. Well, 2x just means 2 times x, so if I want to get rid of that 2, just like with the balance method, I would just divide by 2. But if I divide that by 2, I've also got to do divide by 2 to everything, hence the balance method. So 4 divided by 2, 2, 8 divided by 2, 4. Therefore, I've just changed it to what I've seen before on the very first, the second page. So what could I have? Well, x could be 2, because it's equal to, it could also be 3, and because that's equal to 4, it could also be 4. Same thing for this one. I don't want that. I want it to be an x. Inequality signs stay the same. So how do I go from 6x to x? Well, I divide by 6. Don't forget to do it to everything. 0 divided by 6, 0. 24 divided by 6, 4. So what solutions could I have for x? Well, it's equal to 0, so I could have 0, and then it's bigger than 0, so 1, 2, 3, but it's less than 4. It's not equal to 4, so I cannot include the 4. This one here, again, I just want it to be x. So how do I go from 5x to x? I divide by 5, and obviously you need to divide by 5 both of these. Now, in this case, it's easy. 15 divided by 5, 3. In this case, it's not so easy, so just leave it as a fraction, minus 7 over 5. But what I would do is convert that to a mixed fraction or mixed number, purely because it makes it a bit easier to then do your solutions. So that's what I'm going to do. Minus, how many 5s go into 7? Goes in once. What's left over? 2. Don't forget though, it was minus 7 over 5, so it's minus 1 2/5. Therefore, when I'm doing my solutions, and I'm saying, usually it'll say, tell me the integer values of x. So integer just means whole number values. So what are the whole number values that are bigger than minus 1 2/5, but less than or equal to 3? Well, obviously I can have minus 1, because minus 1 is bigger than minus 1 2/5. And obviously then 0, 1, 2, 3. So by doing that, it just makes it a bit easy to see that you could have minus 1. This one here, again, I'm going to divide by 3, both sides. So that's going to leave it as a fraction as 2/3. And that one I'll leave as 7 over 3. But again, I'm going to convert that to a mixed fractional mixed number. And if you need some help with that, I have done a video on that, so give that a look. How many 3's go into 7? 2. What's left over? 1. And your denominator stays the same. So what are my integer values for x, or my whole number values? Well, what's bigger than 2/3? Well, 1. And then I can have 0. And I can have 1. And this is less than 2 1/3, so I can actually have 2, because obviously 2 1/3 is bigger than 2. So there are my values that I could have there. Okay. And this one here, exactly the same thing. I need to, what have I done there? What a 1, 0. What am I talking about? Sorry. Yeah, I can have 1. And I can have 2. I don't know where I've got the 1 and 0 from, sorry. So yeah, 1 is bigger than 2/3, so 1, and obviously 2 is less than 2 1/3. So yeah, the only solutions there are 1 and 2. Sorry, I don't know what I was thinking there. This one here, again, I just want it to be x. So how do I get this back to x? Well, I've got x minus 1. I want to get rid of the minus 1. So all I do is plus 1. And if you do that to both sides, minus 3 plus 1 is minus 2. 3 plus 1 is 6. There we go. What values could I have? Well, I can't include minus 2, but x is bigger than minus 2. So minus 1, 0, 1, 2, 3, 4, 5. And I can include the 6 there. So 6. And this one here, a few little steps here. So I'm going to take away 3 first. Just as I was solving this equation using the balance method. So that would give me minus 10, 2p, and then 9 minus 3 is 6. Then I would divide by 2. So I'd have minus 5, p, and 3. So what values could I have? Well, I can include minus 5. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, but I can't include the 3 because it's less than 3 and not equal to. Okay, so that's all you really need to know for basic inequalities. If you're on about how to solve inequalities, I've done 2 videos on that, looking at the flowchart or the balance method. So if you need to solve inequalities, make sure you have a look at that video. But hopefully that helps, guys. Yeah, thanks for watching.